Hi, my name is Emma King, and this is my lab for Lab 2 over falling objects for Physics 1. So for this lab, we use Newton's second law to predict an object's motion, and then as compared to last lab, where we had constant velocity, so F net equal to 0, now we have F net being the sum of all the forces acting on the object, which was like the weight force, so we had to consider gravity, and then the drag force acting on the object. And to do this, I did three models, which one was a model using experimental data, a computer model that considered weight force and drag force together, and then one that just considered weight force. And for my experimental data, I dropped a cotton mask from slightly above my shoulder, and I just estimated the weight, and then I used a measuring app to find like the height of the mask, which I then put in Tracker, and then Tracker like calibrated it to be the entire height that I dropped it from, which ended up being 1.6 meters. And this is my Tracker data. And you can see it's different. It's different from last week, and the main difference is that you can see like this is sloping. So that means that the position and the velocity is changing. And this is my computer model that I generated with drag factored in. So I have like the mass of my object, the initial position, which like I said was 1.6, the delta t, which was the frame rate of my video, and then you have j hat, which is just 0, 1, 0, and then the proportionality constant for drag, which was 5 for my experiment. And then the weight force, which equals negative mass of the ball times gravity times j hat, and then drag force, which is b times the y component of the velocity squared times j hat, and then F net, which is just the weight force and the drag force combined together. And then I plug this F net into the equations that we've seen before, which is just VF equals VI plus F net over the mass of the ball times delta T, or the mass of my object. And then the position, which is the final position, equals initial position plus the velocity times the change in time. And the only difference between my computer model without drag and the computer model with drag is that I just set B equal to 0, which changes our F net, because then F net is only going to be equal to W, because FD, which is the drag force, is just going to be equal to 0. So these are my three objects actually plotted after I ran all the models and everything. So the red is the computer model with drag and weight force factored in. Blue is my experimental data, and yellow is the computer model without drag. So definitely the most accurate one is the computer model with drag, but that makes complete sense because drag is going to act on an object in real life. It just doesn't go away. So yeah, and then from this we can like examine terminal velocity, and terminal velocity is achieved when F net is 0 and your velocity is constant. And this happens when the forces acting on the object cancel each other out. So like the force pulling it down is canceled out by the force pulling it up, so like the drag force, and they like cancel each other out, so the object moves in a straight line. And you can see that the model with drag achieves this because it starts to level out, the velocity line does, and you want that velocity line, the velocity versus time line, to be flat in order for like you want a constant velocity. So, and like the no drag just keeps going, but that makes sense because like the force acting against the gravity is gonna be like the drag force, so they can't cancel each other out if there's nothing there, which is what happens when there's no drag. And so like what happens if I threw it? So really it wouldn't make a difference because terminal velocity really stays the same no matter what the like initial velocity of the object is. And also though, in like my model itself, it really wouldn't help, like we wouldn't be able to see that very well just because I only dropped it from 1.6 meters, so that's not really enough time if I like threw it really fast, so like the delta T would be a lot smaller. It wouldn't give it enough time for air resistance to really counteract the gravity because most of it would just be F net because like the initial velocity going down. And since the environment and the objects stay the exact same, there really wouldn't be a change in velocity. And some things I could change is I could actually measure my object. I measure the mass of my object instead of just guessing. And because my mass was flimsy, as it fell, it kind of changed shape, which could affect how drag is acting on it, how like all the forces are acting on it. But yeah, so my lab showed position versus velocity. I use a model, and you could see it like in action and how drag and gravity and weight force all work together to change position versus time.